Hello, my name is George and my teammates are Nancy and Alicia, and we are going to present Newton's laws. First law states that every object will remain at rest of uniform motion in a straight line unless compelled to change its state by the action of an external force. This is normally taken as the definition of inertia. The key point here is that if there is not net force resulting from unbalanced force acting on an object, then the object will maintain a constant velocity. If that velocity is zero, then the object remains at rest. And if an additional external force is applied, the velocity will change because of the force. The materials for the experiments are one glass, one coin, and one piece of paper.
Newton's second law tells us that the more force, the more acceleration, and the acceleration will be proportional to the mass. That means that the more mass, the less acceleration. For the experiment, we will need a glass, a container, a candle, a glass bottle, water, and colorant. Okay, first we need to set a candle on the stretched plate with a few drops of stretch wax. And then mix the food coloring with the water. Fill the dish with the water mixture to a certain point, and it is observed how the water rises and the candle goes down. We see that the candle goes out once it has consumed all the oxygen in the glass, and it is that to continue burning, it needs oxygen. Without the flame, the gases inside the glass cooled down rapidly and cause the pressure inside the glass to drop. The atmospheric pressure from the outside of the glass forces towards the inside of the glass, pushing the water inwards, compressing the air inside the container until a moment comes when the internal and external pressure is equalized.
Newton's third law of motion says whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first. To make it clear, we're going to say that we have two objects, object A and object B. If object A exerts a force on object B, then object B also exerts an equal but opposite force on object A. In simple words, we can say that for every action there is an equal and opposite reaction. For this experiment, we will stick the rope from one side to the other one on a wall. Then we will inflate the balloon, and once we inflate the balloon, we will put a straw on top of the balloon with tape. Finally, we have to introduce the straw already attached to the balloon on the rope, and it's ready. The explanation of this experiment is that when I release my fingers, air pushes out of the balloon. That is the action and the reaction is that the balloon moves with the same force in the opposite direction.
We were able to learn and understand all of the Newton's laws thanks to this work, and we found it very impressive and curious how a single person could conclude three ways of understanding or thinking. Thanks to him, three anomalies of the Earth that are now normalities because we understand them were explained by him.